Ladies and gentlemen, welcome to our Math119 Section 3.1 Number Systems Introduction. This is my lovely looking cousin here. So today we are looking at these numeration systems. We are by far the most used to base 10, where our units digit, each unit is worth 1, and then our tens digit, each unit is worth 10, hundreds, each unit is worth 100, and so forth. But there are other numeration systems, and when we look at the ancient world, there's actually many different systems. The ones that we're going to be most interested in are, right now, the base 5 pieces. So I wanted to highlight that for you in your math activity. Not requiring that you go through and do these problems, but I do want to just highlight it for you. Base 5 is a very common base system, and so this is in respect to the base 5 pieces. When we talk about any sort of a numeration system that's in a base, we refer to the quantities oftentimes as units, longs, flats, and long flats. So in base 5 and in any numeration system, the unit is simply just one of the pieces. A long is the same amount of units as is the base system. So in base 5, a long is going to be 5 units. In base 4, it'll be 4 units. Base 6, 6 units. Base 10, 10 units. A flat will be whatever the base is squared. So this is 5 by 5, so it contains 25 units. And a long flat will be 5 in this system, in the base 5 system. It will be 5 of the flats. So 1, 2, 3, 4, 5. So it's 5 of the 5 by 5s, which is 125 units. So we're very interested in interacting with what's called the minimal collection. And so a minimal collection, here we're shown in this particular problem, says, alright, well, we have two different collections shown here where they both have 36 units, but the second collection, this collection right here, is the minimal collection. So if we look at the left side collection, yes, there are 36 units, but notice that the organization, we've got here 6 different longs and 6 units. Over here, we represent them in as few pieces as possible. So of the 36, the largest of our pieces that we could have is one of the flats, one 5 by 5 or 25. Well, if we take away 25 from the 36, we're left with 11. And so of those 11, we can make 2 longs, or 10, leaving us with 1 unit. Oftentimes, this minimal collection notation is really useful for us. And so this particular minimal collection of 1 flat, 2 longs, and 1 unit, if we are writing that out in base 5 notation, we would say that we have 1, 2, 1, base 5. That does not mean that we have 121 units. It does not, because we just saw this is only 36 units. These are simply placeholders. And so in our minds, when we see this, we should think of 3 distinct different pieces, meaning that I know that I have 1 unit, 2 longs, and 1 flat. You will also be asked on your assignment to rewrite some whole numbers into expanded form. So if you take a look on page 131, there you'll see some guidance on how to do that. So in this particular problem, this example, we have 75,063. And so if we were to kind of break it apart, knowing that we're working within base 10, we know what each of those values is and the place that it holds. The units, tens, hundreds, thousands, and 10,000s digit. So we could rewrite those as an expanded sum of multiplications. This 7 is 70,000, or 7 of the 10,000s. This 5 is 5,000, or 5 of the thousands. This 0 is 0 of the hundreds, so it's holding that place. This 6 is 6 of the tens, and this 3 is 3 of the ones, or the units. And so the sum of those multiplications is the expanded form. There is a second form, and so if you're asked to write the second, it's just a different way of writing it out. So it's the same value, that's still 75,063, but instead of writing 7 times 10,000, the 10,000 is replaced by an exponent, 10 to the fourth, which is 10,000. Instead of writing 1,000, we write 10 to the third. Instead of writing 100, 10 squared. Instead of writing 10, 10 to the first. Instead of writing 1, we write, well, we'd still write 1. You could actually write this as 10 to the 0, because 10 to the 0 is 1, but we don't do that here. On page 134, we see a representation that is in base 10. And so base 10 is obviously what we are by far the most familiar with. It's what most of our numbers are written in. And so this problem is simply saying, hey, these are base 10 pieces. We start off with these hundreds. We have a bunch of tens, and then we have a bunch of units. And so when we rewrite it, we still have 100, or 10 by 10, which is a flat, a 10 by 10, which is a flat, and then we count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of these longs. Well, if we regroup them, we can take 10 of those longs and make an additional flat, and so that's where they get 3 flats. We're left with 1 long, but these units, when you add up those 12 individual units, we notice that we could get 1 long, or 10, out of there. So we'd have the leftover long from before, a long we created here to get 2 longs, and 2 units that are left behind. Base 10 is the only one of our numeration systems where when we write the final answer, the placeholders, we don't write the word 10 behind it, 322, 10, because this is just how we speak, 322. If it's in a different numeration system, you will write the word below it like I did with the base 5 a moment ago.